electric field of dipole. It is very important topic, very important. Remember, it is very important topic, very important. Now, if we are having two charges system, that is minus q or plus q, we can take either way, or plus q minus q inside, separated by d distance. From here we are taking at a distance theta, at a distance r from here, point P. If we are trying to find the electric field at this point, we will find electric field in two components, because we know that electric field is a vector quantity. It is a vector quantity. We have to use the rules of vector. So we will find the electric field first of all in this direction, and we will call it as ER, electric field in R direction. And we will find this in this direction, and we will call it as E theta. Along direction of theta, we will call it as the E theta, and along the direction of R, we will call it as ER. So what we will get it like this here, ER is equal to 2p cos theta by 4 pi epsilon naught r cube. This will be the electric field in R direction. You can see here R direction, and I am skipping the derivation because it is not important for your exam, our NEET exam. It is focusing because it is important for only board exam. So I am taking that question. I will focus on question and concept only. And if we are going to find E theta, what we get? P sin theta, P sin theta, and P sin theta, and 4 pi epsilon naught r cube. Okay, this is in this direction, and in this direction we find like this. Now, since electric field is a vector quantity, what we will do? We will find the vector addition. They are mutually perpendicular. We will find like this: ER square plus E theta square. What we get? We get P cos theta, P by 4 pi epsilon naught r cube under root 3 cos square theta plus 1. Remember, this is very important formula. We will be frequently using it. Very important formula. Very important formula. Remember this. This is magnitude of electric field. What we get? P cos P by 4 pi epsilon r cube under root 3 cos square theta plus 1. From where we have got this? When we put all this value here, we will get this formula. So remember this, first of all, this formula. Second, to find the angle, because it is vector quantity, we have to find the angle. For angle, let us suppose these two vector will add up together and give the net electric field in this direction. This is E, what we have found here, E, this E, it is this E. And if let us suppose this is angle is alpha, we can define like this: tan alpha is equal to, like this, tan alpha is equal to, we can take, we know by vector addition, tan alpha is equal to P cos, P sin theta by P cos theta plus P cos theta plus Q, like this, formula, So similarly, we will use E theta by ER. Since they are mutually perpendicular, we will put theta is equal to 90 degree. We will get this formula. And when we will put this value, E theta and ER, what we will get? We will get half of tan theta. You can put and find out the formula. This is very important formula, and you have to remember this. Very important for your exam. Very important. What is the formula? We will using this in our special cases also. Please remember this formula. Okay. Any problem till now? Any problem till now in understanding the formula or how it is received, how we have got this? You can ask from me, and I will wait for your response in 5 seconds. You can ask any question till now. Any question? Any question from anyone you can ask? Okay. Now, let us move further. Special case. Very important for your exam, NEET exam. First, I have discussed with you axial position, axial position, axial position, axial position. Let us suppose we have said it is plus q, it is minus q, and distance is d. We are discussing about axial position. This is axial position I discussed with you just before one topic, axial position, or it is called as end-on position. End-on position we have discussed. Now, if we are finding electric field or electric potential at any of this point, we can say that at this point theta will be 0 degree. Yes. Aman, please ask your question. Aman, ask your question. Aman, you can ask your question. Very good. Yes, Aman, you can ask your question. Oh, I think. Okay, no problem. Aman, if you have any problem, you can write a message also, no problem. Okay, no problem. When he will come, he will ask question. Okay, now axial position, we can write here E. What will be E? E will be P cos theta. We have learned here 4 pi epsilon naught r cube under root 3 cos square theta. Cos square 0 plus 1. What we will get? This will be 1 plus 4, 2. We will get 2p cos theta. 2p, not cos theta, 2p by 4 pi epsilon naught r cube. Okay, or we can write it like this: 2p is replaced by qd by 4 pi epsilon naught r cube. This will be the electric field at axial position, magnitude. And if we are talking about angle, what will be the angle? Tan alpha is equal to half of tan theta. Tan theta is 0 degree. That means it will be 0 degree. What it is telling that if we are finding the electric field at any of the position on the axial direction, we will get electric field along this side or along this side. Any direction. It is parallel or anti-parallel. First of all, how to calculate this? Usually, it will depend upon the magnitude of the charges because they are equal, but it will depends. Okay. In some of the question, I will show about the direction also. It will either this side or this side. Now, electric field direction 0. It means on the direction of axial only. And what will be its value? Value will be this for axial position. Second special case we are dealing with, which is equatorial position, or it is called as broad end-on position. Broad end-on position. What we say like this: if we are having two charges, plus q and minus q, and if it is we are having a point which is mutually perpendicular at this point P, we are having theta is equal to 90 degree. What we will get electric field? Electric field will be P by 4 pi epsilon naught r cube under root 3 cos square theta. We know cos square theta, it will be cos 90 0 1, only 1. We will get P by 4 pi epsilon naught r cube. You should remember this formula only, and we can replace here 0 degree. Then we will get for axial position, and if we replace here by 90 degree, we will get equatorial position. This will be the electric field for at equatorial position. And when we are talking about angle, we will write tan alpha is equal to half of tan theta. Tan theta is 90 degree, and tan 90, I think it is infinity. Tan infinity, that means we are telling that it is infinity. That means alpha is equal to 90 degree. Okay. Any problem till now? What it is meaning? It means that It means that from here, electric field will be in this direction, here, 90 degree. Any problem till now? Anyone, any problem? Nandini, any problem from your side? Anyone, any problem? These are very much important concept which we are discussing now. And we will frequently using this concept in a numerical also. Yes. Okay, good. No problem. Okay, no problem. Okay, now let us move further. We are moving further. Okay. Let me see what is happening. Sir, sir can revise from first once again. Now I, Nandi, that's good. But I think you can see the video from beginning also. It is available there. So because we have to complete lots of topic and we have a short span of time. Okay. Till now, nothing we have done. We are discussing about electric dipole. Just discussing about electric dipole. Just we have discussed about electric dipole. No, not anything. One homework which I have given to you all. Electric dipole, electric field of dipole, then electric potential, and we have discussed electric field. Then special cases of the two special cases which I have discussed here.